Hello all, welcome back to the video series of real analysis on Ganitha Shastram. In this video lecture, we are going to discuss about theorem related to limit point of a sequence. Theorem 1, Bolzano-weierstrass theorem for sequences. And the statement of this theorem is every bounded sequence has a limit point. Before getting into the proof of this theorem, let me explain the statement of this theorem. Every bounded sequence has a limit point. And we know that a sequence is bounded if all the terms of the sequence lie within two real numbers. And a real number R is called a limit point of the sequence if any neighborhood of R contains an infinite number of terms of the sequence. So here we have to show that every bounded sequence has a limit point, which means for every bounded sequence there exists a real number such that whose any neighborhood of that real number contains infinitely many terms of the sequence. Proof: let Sn be the given bounded sequence with A as its range, and we know that a sequence Sn is bounded, then its range is A is also bounded. So the range A of the sequence Sn is bounded. Then we have two possibilities. First one, A is a finite set, and second one, A is an infinite set. Let us consider the first case. Remember that A is a finite set in this case, and we know that the sequence Sn has an infinite number of elements, but A is a finite set. So there must be a repetition of elements in the sequence Sn. So there must exist at least one element, say psi, such that Sn equals to psi for an infinite number of values of n. This means that if the open interval psi minus epsilon, psi plus epsilon be a neighborhood of psi for some positive real number epsilon, then Sn equals to psi belongs to the open interval psi minus epsilon, psi plus epsilon for an infinite number of values of n. Thus, psi is the limit point of the sequence Sn. So we proved that for a bounded sequence Sn with finite range has a limit point. Let us consider the second case. Before diving in, let me explain the statement of Bolzano-weierstrass theorem for a set, which states that if an infinite set is bounded, then there exists at least one limit point. Since here A is bounded and an infinite set, then by Bolzano-weierstrass theorem for the set A, we have there exists at least one limit point, say eta, then an infinite number of members of the set A belongs to the open interval eta minus epsilon, eta plus epsilon, epsilon being any positive real number. Hence we have Sn belongs to the open interval eta minus epsilon, eta plus epsilon for an infinite number of values of n, and as such eta is a limit point of the sequence Sn. So we proved that every bounded sequence with an infinite range has a limit point.